Welcome to the Occupational Safety Leadership Podcast, episode number 122 with Bryan Haywood. Um, and on today's episode, we're going to talk about confined spaces, both the permit required and the non-permit required confined spaces. Before we really get into it, Bryan, can you do a little background on yourself, please?
Sure, David. So I've been I'm a Murray State graduate, proud Murray State graduate, 1993, and that was back when PSM standard had just come out. So I spent 16 years in petrochem, being a safety engineer, then safety manager, then safety director, then regional, then corporate, and then in 2004, 2005 timeframe, I started consulting, and have been consulting since then. So, and primarily work in, I'll just say, the process safety circles and anything that's attached to it, all the safe work practices, and of course, confined space, lockout. Those are the bread and butter safe work practices that we use on a daily basis. So, that's mostly what I write about and train on and do work around is process safety related matters.
Oh, awesome, Bryan. Awesome. I guess for me, I have just a little bit of PSM. And I'm trying to think what chemicals we had again when I worked at a chemical plant. It was formaldehyde, dimethylamine,
Oh yeah.
chlorine, and I can't remember if I was there when we were phasing in or phasing out ammonia. I kind of forgot which one that was again. But I thought that it was just a fantastic way of doing business. It really made you sit down and kind of look at your process, and just
Hmm.
like literally follow pipes and say,
Yeah.
where does this go and where does that go? Uh, not to delve too much into bad stories, but when I first had graduated college, I moved down to Houston, Texas, and the guy that was living next to me, he was a old guy for a petrochem plant, and so I get to talking to him, and of course he had already called it quits and all that, but he said he was a pointer, and I was like, a pointer? So what's a pointer do? He's like, I go around and I say, about here, I dug some pipes, and we ran them this way. And we did because back then in the 40s, 50s, and 60s, the guys were not really capturing much when it came down to where
No.
piping ran.
Yeah.
And so they would call them back all the time and say, well, we're looking to dig, we're looking to do stuff. We need to kind of understand what people did, so
Yeah.
I
Yeah.
found it really, really just fascinating to talk to them. And when you sit down and think about it, they really weren't doing anything wrong by today's standards, of course. It's really wrong and awful, but they were literally just operating the way that they were told to operate. So,
Yeah. They were just doing what they knew to do. They
yeah,
didn't know any better. Yeah.
right, exactly. Um, so I think I'd like to talk about confined space. Could you
Mm.
just do just a little bit of background on confined space? Because I've only been part of the permit required confined space. And as a young man, when I was a lot thinner and a lot more agile, I could really get into those spaces and do stuff. I don't think I'd like to do that nowadays, So, but if you could take a couple seconds and talk about the permit required confined spaces.
Sure. So, using OSHA's 1910-146 standard, as well as their newer, it came out in 2015, but the construction standard on confined spaces, which is 1926-1201 or .1201 through 12.1213. And they follow the same framework. But the first step in the managing confined spaces is to do your site evaluation. And you have to first determine if the space meets the definition of a confined space. And for a space to meet the definition of a confined space, that space has to meet three characteristics: limited means of egress and getting in and getting out. Um, Not designed for you to be in there continuously, but it's large enough and so configured that you can fit in there and do the work. So that just makes it a confined space. And when OSHA wrote their standard, they basically said, the standard is going to apply to permit required confined spaces. So for a confined space to become recognized as a permit required confined space, it has to possess or have the potential to possess just one of the following four hazards: oxygen deficiency, an explosive atmosphere. Actually, just 10% of the LEL or LFL of the atmosphere has to be achieved for it to be considered hazardous. Inwardly converging walls that slope to a smaller cross section, and then any kind of engulfment hazard, and then any other recognizable safety and health hazard. So I like to say the four characteristics are, atmospheric, the design, which is the inwardly converging walls that slope to a smaller cross section, and then the contents. If you were in there and it was, it had an engulfment hazard, would be a finely divided solid that could engulf you. I also use liquids as an engulfment hazard. So those four things make it a permit required, and we only have to have one of those four. So for it to be a confined space, you have to have all three characteristics. But for it to rise to a level of becoming a permit required confined space, it only has to have one of those four potential hazards. And then once an employer determines that the space is permit required, then the space has to be identified as such. And then the standards, both standards, give an employer basically three options to enter that permit required confined space. The first one is what we call C5. C5 is when you have a permit required confined space and the only hazard that made that confined space a permit required confined space is an atmospheric hazard. And that's a big and, it's underlined, all capital letters and bolded. And the employer can demonstrate that forced air ventilation can control. That's a big word as well, because we're not talking about eliminating, we're talking about controlling the hazardous atmosphere. So, you got a space, you got a blower, you got to make sure that the blower has enough CFM based on the volume of the space, and that the blower can maintain at least 4 air exchanges with fresh air being blown in. We always use positive pressure ventilation in this situation. So that's C5. And in my 30 plus years of doing this, I rarely have ever seen a permit required confined space where C5 was a legitimate option. I'm sure there's some out there, but just not much in like a processing unit or a manufacturing type facility. So then you have what's called C7. C7 is the reclassification from a permit required to one that we call non-permit required. And I'll come back to that one because I'm sure that's the one that everybody wants to hear about. But the third option is what we call D through K. So when you look at 1910-146, C5 is the first option, C7 is your second option. The third option is what we call a permitted entry, and that is all the sections from D all the way through K. K is the rescue section, and that is the one that causes most people most heartburn. And in fact, most facilities struggle to do it correctly. Most don't even come close to doing it correctly. But that is what has driven the option C7 to become more popular. So when you do C7, the reclassification, you can only reclassify a space that does not have the potential for a hazardous atmosphere, and the other hazards, the design of the space, the inwardly converging walls that slope to a smaller cross section, the engulfment hazard, and any other physical electromechanical type hazards like agitators, augers, ribbon blenders, any of these physical type hazards, they are eliminated. Now, not controlled, they are eliminated. So basically, you took a confined space that had hazards in it, and you've eliminated them such that once you get inside, it's like sitting in your office. There's no hazard. There's no potential for atmospheric hazard, which can be tricky because most of the time the atmospheric hazards are created by the work taking place inside the space,
Right.
not the actual space. And then, there all the other hazards have been eliminated via lockout, tagout, or hazards, control of hazardous energy. And once you've done that, then C7 basically says you have to document how you eliminated those hazards. You have to document that there's no potential based on the space hazards or the work taking place inside the space, that there will not be potential for a hazardous atmosphere. And when you do that, then D through K does not apply. So rescue requirements is nullified. You don't have to worry about the requirements. You don't have to wear a harness. You don't have to have an attendant. You don't have to atmospherically monitor the space. Now, I always tell my clients, always do an initial check and always monitor the atmosphere, because you just have no idea what could go wrong. And since atmospheric
Exactly.
hazards are the leading cause of death, and then you just always monitor it. But you don't have to have a rescue team and a rescue plan. So if you can reclassify, that is the one that most people are most interested in. That's what I spent probably the last 10 years teaching companies how to reclassify. But for a facility to reclassify, let's say you have one of your vessels in one of your old plants where you had chlorine, and you wanted to reclassify this vessel, and for you to isolate that vessel, there's only 3 acceptable means to isolate the piping and the hoses and the tubing and duct work, anything that can convey that chlorine to that space. There's only 3 acceptable methods. And this is clearly in both standards, but it just seems like it falls off of people's, they don't read the whole thing. But you have double block and bleed. You have disconnect and misalignment of piping or tubing or hoses or ductwork. And then you have blanking or blinding of the piping. So everything to that space has to be isolated, and single valve closure, single valve lockout does not meet the criteria of what we call positive energy isolation methods. It has to be one of those 3 methods. And a lot of my clients, when they're building a new plant, they know they're going to be going in this vessel on a weekly basis for quality reasons. They'll build in double block and bleed, or they'll put slip blinds in, or they'll put spool pieces in, so they can properly isolate this space in a couple hours versus a day of 2 operators out there. And they're designing the safety into the vessel so it's easily isolated using one of those 3 methodologies. And then they can go into it on a regular basis, and they're designing it. They're designing the safety into the vessel because they know they're going to be going into it. A lot of the old vessels that you and I probably dealt with in our careers, it was single valve. You'd have to go 1,000 foot down the pipe to find another valve and hope there was a bleed in between those 2 valves to be able to get a double block and bleed on that 3-inch pipe going into that vessel.
Yeah.
We just didn't build processes like that in the 60s, 70s, and even 80s. And now, if companies are smart, they will build in the double block and bleed arrangement right at the nozzle at the tank. And I mean, some of the designs I've done for clients, it's literally put 2 block valves in a bleed and then use shark leader or cable, and you can use 1 lock to secure the double block and bleed arrangement in its safe position. So you don't need 3 locks. You have 1 lock, and a cable goes through the 2 closed valves and the open bleed, and 1 lock for that arrangement. Or you put a spool piece in against the nozzle so you can roll it down, and you have a 3-foot gap of pipe, and then put a lock through the bolt opening on the flange, and now nobody can roll the spool piece back in. So there's lot of nifty ways that employers can easily isolate the space, but that's a big miss for a lot of them, is they're not isolating the space properly, but then they're trying to reclassify it, saying that they've eliminated the hazards and single valve isolation. And I mean, I guess it was last year, maybe the year before, OSHA actually came out with a letter of interpretation and finally said that single valve isolation is not an acceptable means for entry into a confined space, or I should say a permit required confined space. So, so if you're going into a space and you don't want to have a rescue team, available, and don't want to have your own in-house rescue team or have to have a contractor there standing by, depending on the level of risk, reclassification is the way to go. If the space can be reclassified, if it has the potential for a hazardous atmosphere based on the work taking place inside the space, then you can't reclassify it. But and there was always the question. I've written about this a number of times. Was, could you use C5 and C7 on the same entry into the same space? And when you look at the flow chart in 1910-146, it clearly shows that there is no correlation between using C5 and C7 together to be able to enter a confined space, permit required confined space without having issued an entry permit. But some folks will, that always comes up as, well, I've got a hazardous atmosphere, so can I use controlled air or forced air to control that hazardous atmosphere, and then do C7, lock out all the agitator blade, and do my lockout on all my isolation points with either double block and bleed, disconnect, misalignment, or blinding or blanking? And my answer was no. That was, the C5 was meant to be its own scenario. C7 was meant to be its own scenario. If C5 doesn't apply, C7 cannot apply, then you have to do a permitted entry. Those are the only three options. And they're in their own little silos, no pun intended, since we're talking about confined space.
That was good.
There's not supposed to be any correlation between C5 and C7 working together to do it. However, I say that, David, but when OSHA wrote the new confined space standard for construction, the way they worded it, you could make the argument that you can use, I think in the construction standard, it's 12.1204G is where they talk about reclassification, and I can't remember the other one, but it's in there. It's the same options. You can, use forced air ventilation to control an atmosphere, eliminate the hazards inside one that doesn't have a hazardous atmosphere, or do a permitted entry. But the way they worded it in the construction standard, it makes it seem as if we can use C5 to control the atmospheric hazard in the space, then use lockout to eliminate the internal hazards, the electromechanical hazards, and the two together would allow us not to have a permitted entry, which again means rescue wouldn't apply.
Right. I never got to that point. Like, we did everything we could. We did forced air, the double block and bleed. We were even pulling it like right from the rail car itself. We disconnected that even and all that stuff, and we never got the atmosphere down to a safe enough level. I think we probably got it maybe to like a 0.5 or a 1 like ppms, but that's still pretty darn awful, with things there like chlorine and HCl and all that stuff. Then we just never got it down good enough. So we did use a combination, but we still did the permit, of course, in this whole thing.
Yeah. When you're doing those kind of things and you're doing it under permitted, you're just doing those to try to improve safety,
right?
For the entrance. But if you can eliminate the hazards. Now, I will tell you this, that if you really get into detailed reading of 1910-146 and you get to the definition of what a hazardous atmosphere is, and you read the note underneath the definition, a lot of people will argue with me that, well, if I'm doing asbestos work inside a confined space, that asbestos makes it permit required. And I'm like, absolutely, it does not. The only atmosphere that OSHA covers under 1910-146 are those acute atmospheres, which would render you from being able to perform self-rescue. So if you're inside a confined space and you're doing asbestos work, OSHA is not going to cite you under 1910-146 if the space is truly just a confined space. The asbestos does not make that confined space a permit required confined space because asbestos exposure is a chronic exposure. So they would cite you under the asbestos standard, not the confined space standard.
Ah,
So,
gotcha.
when you're talking about people being exposed, to a chemical and you're well below the PEL, that's not a hazardous atmosphere. And if you're being exposed over a PEL, but that's a chronic exposure with a chronic consequence or response, that is not covered under the confined space standard. And it's not to say that it's not a hazard and we don't need to address it, but asbestos is the example I give because everybody's familiar with it being, a 20, 30 year latency period. So, doing asbestos work in a confined space, you got to manage the asbestos. It's a hazard, but that asbestos does not create a permit required confined space.
Oh,
So, when we're talking about, what is a hazardous atmosphere, I mean, I know we only got 30 minutes, but I mean, I just did a class for a client not long ago on hazardous materials. And we talked about, how much oxygen is in the air. And, I like to round up to 21%. Well, OSHA says if it's 19.5, then it's IDLH for oxygen deficiency. Well, between 21 and 19.5, if I go from 20.9 down to 19.9, I have lost 1% of oxygen in that space. 19.9 is well above 19.5.
right.
So I know a lot of entry supervisors who would say, well, my meter says I'm at 19.9. I'm above 19.5, so I'm going to put you in that space.
Oh
And
man.
I'm like, no, 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 no. And they're like, well, what do you mean? It's simple math. And I'm like, well, yeah, it is. But you've lost 1% of your oxygen. That means 1% is equal to 10,000 parts per million. You only have a meter that has four gases: oxygen, LEL, CO, and H2S.
Right.
If it's another chemical in there, right, that you can't see, smell, taste, or feel, and it's at 10,000 parts per million, there's a ton of chemicals out there that have IDLHs well below 10,000 parts per million. You could be putting someone into their grave.
Oh
So
yeah.
every program I've ever written, and I learned this in 1994, 95, when we were preparing for putting in place the OSHA standard. I think it came out officially in 96, but everybody in petrochem was doing some model of a confined space entry program because it was such a recognized hazard.
Right.
And, we were basically going, okay, OSHA's going to say 19.5 to 23.5. And that's the bare minimums. We're going to go 20 to 22 is our range for oxygen. And if it's not between 20 and 22, the entry supervisor cannot issue the permit. A safety engineer would have to come from the safety group and fully understand the intricacies of 100% volume of air and what's the makeup of that air and what does 1% of oxygen. You're still above the IDLH for oxygen deficiency, but you've lost 1% of oxygen. There's something in that space. You're not running 99% volume. There's still 100% volume of air. You've just
Exactly.
changed the makeup.
Right.
And we did the same for LEL. I'm just amazed the number of entry supervisors who've been doing it for 20 years and they don't understand the correction calculation on an LEL meter. And they say, well, the meter says 9%. My program and permit say as long as it's less than 10%, you can get in there. Well, you're going into a meter, your meter was calibrated with methane as your cal gas. And in the back of that manual for that meter, there's a correction table. And it says if you calibrate with methane and you're measuring for isobutane, you have to multiply the meter reading by 4.5. So you're not at 9%, you're at 36, 37%. But most people don't know the limitation of that LEL sensor. And they just read the screen and say, well, the screen says 9, 9's less than 10. So here you go. I'm signing off, hop in there. And, they're still a third of they're a third of the way there instead of a tenth. So they're not going to like blow themselves up, but the lack of knowledge of these entry supervisors and the limitations of the meters they're using is, here we are in 2024 and we're still finding this on a regular basis is quite astounding. So
Oh yeah.
we never used 10% in our programs. We always used 2%, because the highest correction calculation I ever saw, and maybe you've seen some higher, was, basically 5, right under 5. So if my program says 2% and the meter's reading 3%, the entry supervisor knows he or she can't authorize entry. They have to call the safety person. So the safety engineer from the safety group goes out and they understand why it's 2%, not 10%. But if it's at 2% and they're in the worst case scenario, the correction calculation is at 5, well, they're still at 10% or less. They're never over 10%. So we never allowed our program to say 10% of the LEL. We always said 2% of the LEL.
Oh, okay. Interesting.
Yeah.
Knock on wood, I only had to tackle like really awful super hazardous chemicals and nothing that would get us burned. The only time I could think of a LEL is that I was on a field construction crew, and I think we went to Columbus, Ohio, and working on sewers. When we went down, 20, 30 feet, that's when we would get about 1 or 2%. So I have almost zero experience when it comes down to like flammable stuff and all that, for
Yeah.
confined space. But
Yeah, you were in my backyard. I'm in Cincinnati, so you were.
I did a lot of work in that area too. So yeah.
Yeah.
So
Small world.
but luckily, I just never had to really factor in all that. I know that it was always rare when it was over zero for us, and that's when we just like always knew like, all right, there's something different, and most of the time when you work with the sewer, you can pretty much smell it. You're just kind of like, oh, so this is like an extra stinky batch, here that we're dealing with,
Yeah.
So, Bryan, I hate to cut you off because we are having a awesome talk, but we are bumping up against time. I'd like to have you back, of course, obviously for as far as I can tell, a part 2, a part 3, and a part 4, if you're going to be okay with that at some point in time there in the future. But I'd like to leave everybody with a way where they can sit down and catch up and ask about any questions they have about confined space and process safety management.
Sure. So anybody can get a hold of me through my website, safetyeng.net. That's SAFPENG.net. You can also send me an email at Bryan, spelled with a Y, BRYAN, at safetyeng.net. You can also, if you're a social media type person, I have a LinkedIn group, and I have a Facebook group under the Safety Eng brand. And that's I think we're about 6,000 in the LinkedIn and a little over 7,000 on the Facebook. And then of course, email me, call me, text me if you got questions, specific questions about anything we talked about today.
Awesome, Bryan. Oh, and before that we go, thank you so much for running those 2 groups. I get a awful lot of tips and tricks from just sitting down and looking at the different questions and comments that other people put in. So it's really good that there's a lot of sharing that's going on out there. So thank you so much,
Yes.
Bryan, for doing that. So
It's my pleasure.
okay, and so that is episode number 122 with Bryan Haywood. Everybody, have a safe day.